Right, we're looking at this topic, electricity in IGCSE physics. So what we have here is a student investigates how the current in a filament lamp changes when the voltage across the lamp is varied. Draw circuit diagram the student could use in their investigation. Right, we need some space, mate. Could draw it here actually. So what we can do is you can have a power, you can have a ammeter, you can have your lamp, now what they're saying actually, when voltage across, okay, so what we can do is this, have a means of and then we check. So remember the ammeter is in series, the voltmeter is in parallel. So let me get this right. This is your power source. So just say this is your battery. Right. That's your ammeter. That's your filament lamp. That's your voltmeter. This is your variable resistor. Right, what does the variable resistor do? It changes the voltage across here by increasing or decreasing the resistance across there. So as voltage drop across here changes, the voltage drop across there will change. Let me get rid of all that. Right, okay, I think that should do it. Right, okay. So I wanted to go through some circuit symbols. Just bear with me 1 second. Right, okay, so we've got the symbols here. If you look at this one here, it's a open switch, so it looks something like this. No, it won't. You can have it like this as well. There's the open switch, there's a circuit, and when this comes down, you draw it like this. You can draw it across like this. That's a closed switch, the closed circuit. Yeah. Now, if you look at, I have a habit of drawing like this, so I know that's the positive, that's the negative. In conventional current, right, listen to this, conventional current, the current flows in this direction. But in the real world, we know electrons flow from the negative side, but we're not interested in that. We use conventional current. So when you've got one of these, it's called a cell, and I always forget. So cell single. If you want lots of cells together, it becomes a battery, and this is how you draw it. Right, and then now we've got this one here. That is a diode. We'll discuss these later. They allow current in one direction. Here's a resistor, just a simple rectangular box, and if you put a line through it, it becomes a variable resistor, so you can vary the resistance. You can increase and decrease the resistance to increase and decrease the voltage in other parts of the circuit. Here's a bulb or a filament lamp. Here's a fuse. That's a fuse, so it's like a resistor, rectangular box, and you draw a line through it. That's the wire that melts in effect, so that is a fuse. Voltmeter is simply a circuit, a circle with the V, measures voltage. Ammeter is a circle with an A in it, measures current. Thermistor is like a rectangular box there, and then you put this line through it. It's like a broken line. The word therm should bring around into your memory something to do with temperature. And the thermistor is a resistor that changes a lot. Resistance changes a lot with temperature, and you'll come across this graph. So this is temperature, and this is resistance. But we'll come across that whenever. You've got a light dependent resistor. So you've got your rectangular box and two rays of light, two arrows pointing in towards it. These special types of resistor. So you've got resistance here, and you've got light intensity here. So when it's dark, you have high resistance. When it's light, you have low resistance. So it's a special type of resistor. So this is your first type of special resistor. That's your second type, and then you've got the diodes. It's that one there. And remember, the idea behind that is it only allows charge or flow or electrons to flow or current to flow in one direction. Right, and right, let's just leave it like that for now. We can build on that. Right, okay, graph shows the students' results. You've got voltage, you've got voltage here, and you've got current here. Describe the relationship between the current and the voltage. Right, it's a 2 marker. Right, so the first thing you've got to write down is, right, for the first mark, as voltage increases, basically whatever's on the x-axis, the current increases. Right, that's the first mark. Second mark, is it a linear relationship or is it non-linear? It's not straight line. So it is a non-linear relationship. This is one thing you've got to be careful with physics. It's a bit stranger than the other subjects in terms of what it wants you to write down. Just be aware of that. Right, state the formula linking resistance, voltage, and current. You know, with these, it's good to know these off the top of your head. It's fair enough having a formula sheet, but the more you practice, the better you become at it. So you can put V equals I R, or voltage equals current times resistance. Right, okay, so what we need to do is use the graph to determine the resistance of the filament. So we're trying to work out the resistance of the filament lamp when the voltage is 7.2. So what they want us to do is, when the voltage is 6, 7, look, if I did 7.1, 7.2, 7.3, 7.4, 7.5, that would be wrong because we've hit 8 already. So it's going to be 7.2 here. Okay, 7.2 is there. So all I do is draw a line, get a ruler. So remember, ruler, don't be lazy, goes to there. And then you just draw a line across there. Show your lines. I like to see the lines. It'll help you anyway. Right, so look, we've got 2 point. What I do is I test it. So I do 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9. Oh, 3. So it's not that. Right, so what you do is, let's not try to rub that off. There you go. So I know it's not 0.1. So I know this 5.50. So every 2, so that would be 2.1. Every 2, 2.2. Every 2 squares, 2, and 2.4. 2.4. So we're expecting a current of 2.4. Right. 2.4 2.4 amps is the current. Right, so now we're going to use this formula that they've given as a hint to. So voltage equals I times R, current times resistance. We've got the voltage of 7.2 equals 2.4 times resistance. We rearrange this. So write it, just out of habit, write it like this, and then rearrange it. R equals 7.2 divided by 2.4. And that will give you your answer. So we can write 3.0 ohms. Yep. Okay. Right, what we're going to do is, okay, let's do one more question on this video. A family has a television set. When on standby, the power rating is 0.27 watts. So power is measured in watts. Calculate the energy transferred over a period of 12 hours. Okay, so power, we're looking at energy transferred is energy divided by time. So we want energy, so let's put the values in 0.27. Remember, with physics, it's put the values in and then rearrange it. So we'll just put E over, right, we want that in seconds. So what we do is we do 12 times 60 minutes times 60 is 43,200 on your calculator. So 43,200, and then rearrange this. Now write it in the form E equals 0.27 times 43,200, 43,200, and the answers joules. Suppose because they've not given a unit, you could put 12 kilojoules, but you'd have to state the units. So just bear this in mind, just looking at the mark scheme. Formula, substitution, rearrange, and then evaluate it. Okay, it's interesting that they want that sort of structure, but let's run with that, there's no problem. Right, in normal use the current is 0.31 amps, so current is measured in amperes or amps. Explain how the fuse works to protect the television if there is a fault. So if current gets bigger than or exceeds the fuse size or the fuse rating, try to learn these words. So if current gets bigger than the fuse rating or fuse size, okay, the fuse wire melts or breaks, so the you can then say the device, this is how they've worded it, is isolated. Basically the current stops flowing. But if this is what they like, we've got to learn these phrases. Yeah, the device is isolated. So there's three things. If the current exceeds the fuse rating, the fuse wire melts, so the device is isolated, so current stops flowing. Right, okay, explain why a 13 amp fuse is not appropriate choice for a fuse to use in a plug on this television set. Now, the reason is, right, the fuse rating or fuse size, is much bigger than the normal current that's being used. So if there is a fault where you've got a large current going in, if there is a fault, the fuse will not melt and the current coming through, the current may damage the TV set, or even worse, set fire to it. So just look at the idea. So normally there's this much current going through, something like this, yeah? Right. You've got a fuse here with that wire. Suddenly what happens is the amount of current coming through, right, will melt this. So the device is isolated. What's going to happen now is, if you had this situation, so you've got current going through, But now here your fuse has got a super big size of thick wire. Yeah, so your TV only needs this much here, but your fuse can handle lots. So if there's a big current coming in, this will not melt, so the current will carry on going, and it might damage the TV set. Right, okay, I hope that helps. Right, we'll call it quits there. I'm going to try to make these short because I'm trying to get my head around this as well. Inshallah. Okay.